Hey class, it's Tom with mini lesson 2 for unit number 1. So what I'm showing you is what's called an outcrop. It's a superficial expression of bedrock, and this particular bedrock belongs to a geological formation called the Stockton Formation, which usually is comprised of sandstones, shales, silts, mudstones, and limestones, and in this area it appears to be mostly shale. So if you look at the horizontal lines going across the face of the bedrock, these are called bedding planes, and why I am showing them to you is because they serve as preferential pathways to water flow. So if you look at the trees above, as the water from rain percolates through, it reaches these bedding planes, and they are visible to the eye. There's space there for the water to flow through. In fact, if you were close enough, you could see some icicles in the 30s today. This water eventually makes its way down to this feeder creek. This is a feeder creek to a much larger creek. It's affected by the change in elevation. In some areas it's sudden, so you get more rapid movement. In other areas it's slower. But in general, I'd say you're looking at a range of 5 to 15 degrees. So when we studied ecosystems in our readings, we talked about abiotic factors and biotic factors. So I'm going to mention those to you today to see how they interact with each other. They're all part of the ecosystem. So how does the abiotic factors of this bedrock interact with the biotic factors within this stream? Well, let's take a look. So there are minerals in this shale, and they're released into the creek via a process called weathering. It's a term used to describe the breakdown of bedrock into its minerals via precipitation, freezing, and thawing, as well as a gradual dissolution from an organism called lichens. I'll explain lichens in more detail later in this lesson. So precipitation runoff, it's also referred to as stormwater, carries these minerals from the rock into the surrounding environment in a dissolved state. So the flow rate of the creek, its temperature, its pH, and the existing concentrations of dissolved minerals in the water in the creek, that will all influence the degree that these minerals will migrate. And eventually, they will transform back to the solid state wherein they can settle into the creek sediments. And again, those factors of flow rate, temperature, pH impact when they come out of solution and become a solid and fall down to the bottom of the creek. So if you've ever dissolved salt or sugar in a glass of water, if you put too much in, not much more will dissolve and it will fall to the bottom. That's the concentration affecting the solute. Again, temperature, hotter water, you'll be able to dissolve more. pH, the higher the pH, the more readily that minerals will fall out of solution and down to the base of the creek in the sediments. Okay, so there are some biotic factors. So what other some abiotic factors. What other abiotic factors do we have going on? So we have some leaves here. You can see they're going and making their way into the creek. And when they reach the creek, they start decaying. We learned about a term called detritivores. Detritivores are organisms that can break down organic matter. The nutrients from the leaves, like nitrogen, then are available to the organisms in the creek. And I mentioned earlier an organism called lichens. I believe I saw a pretty good example on my way to this spot along the creek. There we go. So I want to show you what lichens look like. They're really unique. They're a combination of fungi and algae, and they live together in a symbiotic relationship. And we learned in our readings about mutualism, where one organism benefits the other as they live together. And that's what lichen are. They are mutualistic organisms living together. You can see them by these irregular, almost circular shapes on the top of this example of a shale piece of the outcrop that has broken off. So what happens is the fungi actually secrete a weak acid, and that dissolves some of the nutrient-rich minerals in this shale rock. Those minerals are taken up by the algae as a food source, so the algae benefit. But the fungi benefit from the algae because the algae are primary producers, and they go through the process of photosynthesis, which produces energy for the fungi. Recall in our photosynthesis equation, glucose is a sugar. That's the energy source for the fungi. So we have this mutualistic relationship, which is not only helping out the fungi and the algae, but it's also breaking up this rock so it's more exposed to that weathering process I mentioned earlier. That releases more minerals. And again, when you have stormwater runoff, you get the minerals from these decaying rocks and decaying leaves, and they end up into the creek. Okay, so what happens when we get mineral and nutrient-rich materials entering into the creek? How does that affect the biota? So here's a very shallow portion of this creek. And so what we're going to talk about first is what are in the sediments as far as the biotic nature of this ecosystem. So we talked about the lichens. What these minerals and nutrients that reach this creek do is they also support life for plants, moss, and a host of organisms like insect larvae, crayfish, and many other macroinvertebrates. That's just a term of an organism you can see with your naked eye, but it doesn't have a backbone. So they all feed off of these nutrients and minerals. And the detritivores that live in the sediments, such as worms and other nematodes, they break down the organic matter to release even more minerals and further support the plant and moss growth. Okay, so there's your primary source of nutrition, feeding the producers. Now we'll look at a little food web here. What do these producers serve to do? Not only do they provide energy, but they're a food source for small fish, like a swallowtail shiner. It's about 1 inch long. That swallowtail shiner will feed on the plants and moss, and when it makes its way to the deeper creek, it itself becomes prey for about a foot-long trout. And that trout itself becomes a prey for a larger eagle or hawk. So we have a very basic, simple food web here, but it all depends on the abiotic environment, starting off the feeding of these sediments. So what would happen if this entire creek bed were excavated and replaced with a concrete sluice, and that sluice was routinely vacuumed so there would be no accumulation in it? What would happen to the food web? Think about that, and let's discuss more. Hopefully we've all voted on the survey to have an open class forum, and I'd love to talk about it more. Take care, class.